Okay, so today I want to talk to you about how we solve inequalities. Now, with inequalities, they're very similar to equations in the sense that you treat it like an equation unless a certain thing happens. So here we've got 3x minus 10 is less than 2. Okay, so we're going to solve this like it were a plain old equation. We're going to imagine that this here is just an equal sign. So if this were just an equal sign, what would I do? 3x minus 10. My goal at the end of the day is to find the value of x. So in order to do that, I need to move everything away that is an x. So I need to get rid of the least attached thing to my x. So that's the 10. So what's the opposite of minus 10? I'm going to plus 10 to both sides. Cool. So they've cancelled out. So on this side, I'm left with 3x. I've got that symbol that I'm just carrying down. And 2 plus 10 gives me 12. Okay. Now, I want to get x on its own. 3 and x are married together. How do I break them up? I have to divide them. So divide by 3, divide the other side by 3. They've cancelled out. So x is less than 4. See how nothing changed? We just pretended that that was an equal sign because the certain thing that happens that changes the symbol didn't occur. However, it will occur over here. So let me show you what I'm talking about so I don't sound so crazy. All right, here I've got x minus 3 over minus 2 is less than 5. Okay, so to start, we're just going to pretend that that's an equal sign. Okay, so if that were an equal sign, what's the first thing I do? Well, I need to get rid of this minus 2 down here. How do I do that? I have to multiply by minus 2. So times minus 2 times minus 2. Okay, so that's where this interesting thing happens that changes our inequality symbol. So anytime you multiply or divide by a negative number, this is going to flip the other way. So let me write that up here. Okay, so here's our rule. Anytime you divide or multiply by a negative number, it flips your inequality symbol the other way. Okay, so because that's happened, this has to flip the other way. So I'm going to rewrite all of this. They've cancelled out. Now I've got x minus 3. This has to flip. So instead of facing that way, it'll be facing this way. And now 5 times negative 2 gives me negative 10. Cool. See how that has turned into this because I multiplied by a negative number. Okay, now let's see what happens. So now I'm just going to treat it like a plain old equation. So I need to get x on its own. I've got x minus 3 is greater than minus 10. What's the opposite of minus 3? I need to plus 3 to both sides. Plus 3, plus 3. They've cancelled out. So here I've got x is greater than negative 7. Cool. And that's how we do inequalities. So you treat it like a plain old equation. Nothing is different unless you multiply or divide by a negative number, in which case your symbol flips the other way. All right, so here we have a couple more of these inequality questions. I'm going to leave the rule up there so we remember that. Okay, so we've got 2x plus 8 is greater than or equal to 24. That's what this little sign here means, greater than or equal to. Now let's solve this like it was a plain old equation. So I've got 2x plus 8. I need to get rid of this 8, so I need to minus 8 from both sides. Minus 8, minus 8. So they've cancelled out. Now I'm not flipping my sign because I didn't divide or multiply. I've just minused 8. Okay, so it's important that you remember that you only do it when you divide or when you multiply by a negative number. Okay, so now I've got 2x is greater than or equal to 16. Cool. All right, so now I need to get x on its own, so I need to divide by 2. Divide by 2. So x is greater than or equal to, how many 2's go into 16? It'll be 8. Cool. We didn't have to flip our symbol at all there. Let's try this one. Okay, this one here, we've got fractions. Now, I love fractions. Everyone hates fractions, but I love them. They're actually really easy if you do it this particular way. Don't bother with all the cross multiplying gibberish that people talk about. I don't find that that is a good method at all, in my personal opinion. So the way that I like to do fractions, especially when you have, this works especially well when you have multiple fractions, is you find a number that your denominators go into. So my denominators are 2 and 6. I need to find a number that both of those fit inside. So 2 actually goes into 6. So what I do is I put a 6 in the front and I put all of this in brackets. Okay, so 6 is my chosen number because 2 fits in 6 and 6 fits in 6. Okay, so I'm going to put this in brackets and I'm going to put that 6 in front, and I'm going to put this in brackets and put a 6 in front. Okay, because 6 is my chosen number that all of my denominators fit inside. So now I think to myself, well, how many times does 2 go into 6? It goes in 3 times because 2 times 3 is 6. So that has essentially cancelled those two things out. So what's left? I've got a set of brackets with 3x inside. All right, now let's do this one. How many 6's go in 6? Just 1. I don't even really need to write that. So they've just cancelled each other out, and all I've got left is an x in a set of brackets. I don't really need the brackets there either though. So, you know what? Let me rub those out. Okay, and then here, I've got greater than, I've got 6 times 6, or 6 in brackets, 6, which just means 6 times 6. Okay, cool, all my fractions are gone now. Hooray! And now I can solve it. So I expand this set of brackets here. So 3 3's are 9, so that gives me 9x plus x is greater than 6 6's are 36. Cool. Now I can add these two because they're like terms. So that gives me 10x is greater than 36. And now what do I do? Well, I need to get x on its own, so I need to divide both sides by 10. Divide by 10, divide by 10. So x is greater than 3.6. Cool. I also didn't have to flip anything because I wasn't multiplying or dividing by a negative number at any point there. Cool. Alright, now we've got 2 more examples. Had to put some more fraction ones in there because I love fractions so much. But anyway, let's do this one here. Okay, so I've got 4 brackets, negative 2x plus 1, close brackets, is greater than or equal to 25. Alright, so our first step is we need to expand our brackets. So everything inside the brackets gets multiplied by what's in front. So 2 times negative 2x gives me negative 8x. 4 times 1 gives me 4. Is greater than or equal to 25. Okay, got to get x on its own, so I need to move everything away that's not attached to my x. So I've got to get rid of this 4. So minus 4, minus 4. So that's cancelled out. So here I've got negative 8x is greater than or equal to, that'll be 21. Ooh, that's not a nice round number. Oh well, whatever. Okay, we'll end up leaving our answer as a fraction. Okay, so now I need to get x on its own, so I need to split up this minus 8 and the x. So I'm going to divide by minus 8, divide by minus 8. Okay, now because we are dividing by a negative number, this needs to flip. Okay, because I'm dividing by negative 8 on both sides. So that's cancelled out, so I'm left with x. But instead of facing that way, it's going to be facing this way. And then it'll just be 21 over negative 8. Cool. And there's our answer. Let's do this one. So I've got 2 sets of fractions, so I need to find a number that both of my denominators will fit inside. Okay, so the easiest number that I can think of is 10. So I'm going to be putting all of my components inside brackets and putting a 10 in front. So brackets, put a 10 in front. Brackets, put a 10 in front. And brackets, put a 10 in front. Cool. So now I have to think to myself, how many times does my denominator go inside the number that's in front? How many times does 5 fit in 10? 2 times. So I put a 2, and that has cancelled those out. Now what's left? I've got an x in brackets. Now here, there's no denominator, so I just have to leave it as it is. Okay, then I've got this symbol. How many times does my denominator fit inside here? 2 goes into 10 5 times. So then I've got brackets, and then I've got negative 2x, because those are cancelled out. Cool. No more fractions. Super easy. I don't know why people panic about fractions. Anyway, all right. Now we've got a bunch of brackets here that we need to expand. So 2 times x gives me 2x, plus 10 times 1 gives me 10. Then I've got 5 times negative 2x. That gives me negative 10x. Cool. Something weird is happening here because I've got x's on both sides. So I need to pick a side to move my x's to and leave my numbers on the other side. So I'm going to move this 2x over to here. That way I'll just have the number 10 left on this side. So how do I move a 2x? I'm not trying to split them up, so I don't want to divide or anything. I just want to move them. Now, a lot of people get stuck when they get to here and they're not sure how to move something like this. So think to yourself, is this a positive 2x or a negative 2x? It's positive because it doesn't have a negative symbol. So if it doesn't have a negative symbol, you assume it's positive. So this is positive 2x. How do I move plus 2x? I minus 2x. So minus 2x, minus 2x. So they've cancelled out. So all I'm left with here is 10. Then I've got my symbol. It hasn't flipped because I didn't divide or multiply, okay? I just minused. So I've got negative 10 minus 2 gives me negative 12x. Now I need to split my negative 12 and my x up because they're married together. I need to divide them. So I'm going to be dividing by negative 12, dividing by negative 12. Now because I'm dividing by a negative, this symbol flips the other way. So they've cancelled out. So all I'm left with over this side is x, but this symbol now faces the other way. And I've got 10 over negative 12. Actually, I can simplify that. Hang on. Let's see. That'll be negative 5 over 6. Cool. So inequalities are super easy. They are the same as plain old equations unless you divide or multiply by a negative number, in which case all that happens is your symbol reverses, flips the other way.